So now we are going to discuss the different types of energy loss in transformer. So we already studied what the construction, working and principle of transformer. So what are the energy loss in transformer? First, copper loss. So what is copper loss? The energy loss due to heating of the primary and secondary coil which are made of copper in transformer. Okay, so the energy loss due to heating of the primary and secondary coil which are made of copper in the transformer is known as what? Copper loss. Then iron loss. So iron loss is again divided into two parts. The energy loss which is known as iron loss is divided into two parts. One is eddy current loss and the other one is hysteresis loss. So what is eddy current loss? The loss in energy in the transformer due to production of heat by the eddy current which is produced in the iron core. Clear? So eddy current loss is the loss in energy in the transformer due to production of heat by the eddy current which is produced in the iron core. We know already that in the construction of a transformer we used a soft iron core on which primary and secondary coil are very closely wrapped. So the production of eddy current in the iron core produce some heat which will cause some energy loss, that is known as eddy current loss, which is a part of iron loss. Next, hysteresis loss due to alternating current, as we supply an alternating EMF as input, so it will produce a alternating current. So due to alternating current, the iron core gets magnetized and demagnetized repeatedly in opposite direction, due to which some energy get lost, that is known as hysteresis loss. So next important loss in transformer, that is loss due to sound. Third, energy loss due to production of sound in transformer. Okay, basically the cause of the sound is eddy current. Okay, as eddy current produces in the different layer of the thin metallic sheets in the iron core, so they will repel each other. That's why there will be sound, and that sound production due to the eddy current is cause some energy loss. Next, loss of energy in form of flux leakage. For loss of energy in form of flux leakage. So these are some energy losses in transformer. Okay, so now if energy loss in transformer, then what will be its efficiency? It's sure that the efficiency of the transformer can never be 100%, as the input amount of the EMF and the output will be differ, because there will be some loss of energy. So the efficiency of transformer which is denoted by eta equal to total output divided by total input. If we want to calculate in percentage, it will be into 100%. So what is the total output power? Total input power. So total output power, we know ES, the EMF across secondary, into current across secondary, divided by the EMF across primary into current across primary, into 100%. This will be the percentage of the efficiency of a transformer. Clear? So what are the energy loss in transformer? We already studied now. And how to calculate the efficiency of a transformer, which can never be 100%, because there is some loss of energy in different form. So this is the expression for efficiency of a transformer: total output power by total input power. Okay, so now how transformer is used to transmit current for a long transmission line. So how current, alternating current, get transmitted from the powerhouse to the consumer, which is a very long transmission distance. So that's why the transformer are used. So as we already studied, if here is the power plant where the alternating EMF is produced, okay, input. So at this point, here is the users. So we have to use. So it's a very long distance in the form of some kilometer, 100 kilometers or 1000 kilometers. So how to transmit alternating current through the transmitting wire without a significant loss of energy in it? As we already know that when current travels through a resistor or connecting wire, there will be some energy loss in form of heat, which you can write H equal to I square RT. If current is the amount, this is the resistance, this is the time. So when resistance increases, the heat produced will increase. So how we have to minimize this heat produce? So when at the power plant, heat is the alternating EMF is produced, it is supplied to a step up transformer. What is step up transformer? We already know. In a step up transformer, the current is converted from lower potential high current to high potential low current. That means the step up transformer will convert current from high to low and increase the potential from low to high. So when we use a step up transformer at the power station, so it will give a output which have low current, high potential. So the heat generate during the transmission of the current will be low, because R is constant, because we know R equal to rho L by A. So rho is constant because we cannot change the rho from iron or copper, silver to any costly material, because it will be more costly, and to decrease R we have to increase area. So if we increase the cross sectional area of the connecting wire, it will be more heavy and more costly, which is not beneficial for us to transmitting current for a large distance. That's why, and the length, it is remain constant, because we cannot decrease the distance between the power station to the consumer's home. That's why L remain constant. So we cannot change resistance. So we have to change what? I, because we cannot change time. So we have to change I. How we can change I? If we decrease the value of I, the heat produced will be decreases. That's why we have to use a step up transformer, who will decrease the value of current and increase the value of potential, and then the output will transmit through the connecting wire for over a large distance, and it have less amount of current, high potential, so the energy loss will be minimum. Then it will get imported through a step down transformer at the substations, which is near the locality of the users. So by the help of a step down transformer, in step down transformer, the number of turns in the primary is large and number of turns in the secondary is less. So we have to use a step down transformer at the end or the substation, where the current, this current have less potential. high potential and less current value. High current at high potential, low current. Transmission is the current is transmitted from power station to users, and here it is a step down. This is step up. So and at the substation the current will get step down, so we will get low potential, high current, which we used in our household service. Clear? This is how for a long distance transmission we use transformer. A step up transformer is used as the power station, which will increase the potential and decrease the current value. That's why the energy loss during the transmission will be less. And at the user or the substation there will be a step down transformer, which will again convert the high potential low current into low potential high current. Because if we use the high potential low current in our day to day life, it will be more dangerous, because the potential of the current will be very high and the appliances we used in our household will not resist to that amount of potential. That's why it have to again convert into low potential and high current. So this is how transformer is used during long distance transmission of alternating current from the powerhouse to the consumer house. Okay, so this is all about alternating current. We already studied what is transformer, how different kinds of circuit containing different elements, what is resonance, and all the things. So next class we will discuss some numerical based upon this. Okay, thank you.